Okay, in this video we will talk about critical values for different types of tests. So if you look at 1, 2, and 3, you'll see that in 1 we have a right-tailed test, and in 2 we have a left-tailed test, and in 3 we have a two-tailed test. But notice that the test, it's called the Z test or the Z test. This is the traditional approach test. Or you can also call it the critical value approach, or the Z value approach, or just the Z test. Also the traditional test, if you like. So after we solve these questions, we need to also read what says below. It says in each question, express the rejection region, which we also call critical region, and the non-rejection region, which we also call the non-critical region, mathematically. Okay, but before we start, I need to tell you something. This alpha that you see here in the 3 questions, it is the level of significance. I want to tell you what it is. Alpha is called the level of significance of the test that you are performing. Significance. And it is at the same time, and this is the important thing that I will write now, it is the area of the critical region or the rejection region. So you can do RR to mean rejection region, or we can also say it's the critical region. So the area of the critical region or the rejection region is alpha. Okay, so now I want to show you how to solve these questions, and also talk about the critical region or rejection region and why it's called rejection region. So let's go to the first question now. So here you need to determine the critical value, which we call also CV for short, for a right-tailed Z test, and alpha is given here. So we have a right-tailed test, so immediately the picture looks like what you see. And the critical value is always this number here. This is the critical value that we're looking for. So alpha that you see here, it is the area of the rejection region. So this is alpha. Alpha, in this case, of course, it's given as 0.015. Because it's a right-tailed test, that's why alpha is to the right. And what I want to show you now is that once you compute the critical value, what is significance about it is that if you draw a line here, then the rejection region becomes the region that is to the right side of the critical value for a right-tailed test. So the other one, this here is the non-rejection region. Okay, so this is for a right-tailed test. If you want to know, I will move quickly just to show you. For a left-tailed test, this is the picture, and for a two-tailed test, this would be the picture. But we will talk about these when we get to them. Now, when I say rejection region, what do I mean by this? This means that you will reject H0, the null hypothesis, if your statistic value is above the critical value for a right-tailed test. I will talk about this in a little bit. So for now, just know that the rejection region means it's the region where you would reject the null hypothesis. And the non-rejection region, this is the region where you do not reject the null hypothesis H0. Okay? So now, the question is, how do we compute this critical value? That seems to be very important because it's dividing the normal distribution into 2 parts. One part is rejection region and one part is non-rejection region. So how do we compute it? It's actually the same as computing a Z value. So for example, here the probability that Z is, we need to find this critical value. You know, I will put an equal sign here, and we are waiting to find what this critical value is. So the probability that Z is less than this critical value is equal to, this is the area to the left of the critical value, but we are given alpha. Alpha is the area to the right in this case because it's a right-tailed test. So in this case, the area to the left is going to be 1 minus the area to the right, which is alpha. So 1 minus alpha. And if you do 1 minus 0.015, you'll get 0.9850. Okay, so this is the area to the left of the critical value. So immediately we can now use the Z table because we have the area to the left. And because I made so many questions on the Z table, I will skip showing you the Z table now. Please get it and look at it to just verify what I'm telling you. And if you don't know how to use it, then go to the 6-part video where I teach you how to use the Z table. So now, from the Z table, you look in the body of the table, you'll find that this critical value is equal to 2.17. Please look now at your Z table and make sure that this is the correct Z here. And so go back to the critical value and you can write here it's 2.17. This is a very important number for you now for this question because it will separate the rejection region from the non-rejection region. So you can say, therefore, the critical value for this question is equal to 2.17. That solves the question already, of course, but I added to you, if you remember, I added this part where I said express the rejection region and the non-rejection region mathematically. So this is what I'm solving now. So you can say, because we found the critical value, now our rejection region is, and now you look, where is the rejection region? I'm going to draw it in black. You see, it's this here. This is the rejection region, okay? Which is, of course, you get it from the x-axis. So you look at all the values that are bigger than the critical value in this case. So the rejection region is Z bigger than 2.17. Let me just say something. This means that if you compute the test statistic, and I will go now and show you where, yeah, so depending on your problem, you will compute Z. You know, in 3 cases you compute Z. I have the next part is about the T distribution. So now if you have one of those 3 situations, then this is the Z that you compute, okay? Any of those 3, depending on the question, of course. And then you come back and you check it here. Your Z, you check it here. If it's bigger than 2.17, then you reject the null hypothesis. You would say we reject H0. And if it's less, so if you have a Z here, for example, or here, when you use that formula that I showed you, then you do not reject H0. But if it turned out to be here above the critical value, then you reject H0. So now we will write also, so you can say, and the non-rejection region is, and let's see, it will be the opposite. It is all the test statistics, the Zs, that are less than or equal to the critical value, 2.17. Okay, so let me make them easier to see. So I will put this in this color and this in this color, okay, and the critical value in this color. All right, so this is for a right-tailed test. Let me go to the next one, and you will see what happens in the situation of a left-tailed test. So it's exactly the same question, but in this case, it's a left-tailed Z test, and the level of significance, or the area of the rejection region, is 0.05. So again, this is the critical value that we are looking for this left-tailed test. So we will find it. Here, of course, this is the area of this is alpha, the level of significance, which is 0.05. And this makes it very easy to find the critical value because you have the area to the left of it. So you can say the probability that Z is less than this critical value is equal to alpha. It's 0.05. There is no need to do 1 minus because we have the area to the left already. And so, again, we use the Z table here to get the critical value, but I will leave it for you to find. you will find that this critical value is equal to, if you look at the Z table, it will be minus 1.645. Okay, and please, again, for this one, check the Z table, make sure that you understand this. So I will put it here, it's minus 1.645. And it is separating, so now we will draw this vertical imaginary line. And for us now, the rejection region is here. This is where you reject the null hypothesis. If you get any test statistic here, like if your Z is here, less than the critical value, then you would reject the null hypothesis. This is the traditional method. And the other region, the one to the right of the critical value, in this case, it will be the non-rejection region. Okay? And so let us now write everything as we did in the first part. So remember, you can say here, therefore, my critical value, the question could be just to find the critical value. So you can ignore this rejection region and so on, but it's better to understand it now when you are doing the critical value. So in this case, we found it to be negative 1.645. And because it's a left-tailed test, you can say from this we get that the rejection region or the critical region is, and in this case it will be any Z that is less than the critical value, 1.645. So here is our rejection region, and I will put a square around it or a rectangle. And now also the non-rejection region. Remember, rejection and non-rejection for what? For H0, for the null hypothesis. So the non-rejection region in this case is any Z that is bigger than or equal to the critical value that we found, minus 1.645. That's how we write the non-critical or non-rejection region mathematically. So here is the answer to the non-rejection region for this one. So again, I will just quickly go and show you something. In this table, of course, again, we are doing the Z test. So when you have the Z value, it's one of these three situations. Notice that when the population standard deviation is known, sigma, then it's the same formula for Z. Otherwise, if sigma is unknown, look at what it is. It's just the S here replacing the sigma. S is the sample standard deviation. And again, I will remind you, I will have a specific part of this string of videos on the T distribution. So for now, this question is about the Z. So it's one of the three cases that I'm highlighting. So now you compute this Z. So x bar minus mu over sigma over radical n, and then you check it against the critical value. Let's say that your Z turned out to be here, or here, or here. Then, because you are in the non-rejection region, you will say, do not reject H0. So here you will say, do not reject H0. All one sentence, of course. If your Z that you compute from that formula turned out to be here, anywhere here, then you would reject the null hypothesis. So you would say, reject the null hypothesis H0. Okay? Now, we will go to the last one. Let me just fix this. Sometimes when I'm writing, my hand gets in the way and erases something. So, sorry for this. It happened in some videos before. I try not to make it happen. So let's go to the last part of this, which is a two-tailed test. So now we have a two-tailed Z test. So traditional method, or Z value method. And we need to find the critical value, and our level of significance is 0.2. But remember, this level of significance, this alpha, is the area of the rejection region. Rejection region. And in this case, notice that we have two critical values. We have this one, we can call it critical value 1, and this one here, which we can call critical value 2. They will be negatives of each other's, of course. And I will just put equal in a box because we will find it very soon. And this one equals, and we put it like this. If you find one of them, then the other one is just the negative of it. So it's very, very simple for this one. So as you can guess, we will find the critical value 1 because we have the area to the left of it. So that would be easier for us. Before we do this, I want to just tell you something. Here, the rejection region is going to be 2 parts. It will be anything here. So this will be our rejection region, and anything here, our rejection region. Both of them, you would reject the null hypothesis. And the thing in the middle here, this is the non-rejection region. Okay, so if anything lies between the 2 critical values, if your test statistic lies there, the z that you compute from this formula, if it lies somewhere between, then you will not reject H0. But if it lies, let's say, here or here, then you would reject H0. Okay? Now, I need to tell you last thing about alpha in the case of a two-tailed test. Because it's a two-tailed test, alpha is the area of the rejection region. In this case, it's 2 parts. It's this part and this part. That's why to get the area of this one of the 2 parts, its area will be alpha over 2. So this will be 0.2 divided by 2, which is 0.1. That is why, if you want to compute now this critical value, you would know that the area to the left, which is the probability that z is less than this critical value, this is now alpha over 2, which is 0.1. Make sure that you understand this. You have to divide alpha by 2, because alpha is the total area of the rejection region, and in this case, it's 2 parts. So if you want one of the 2 parts, you need to divide by 2. So if now you use the z table to get the critical value 1, and I will leave it for you again. So you will get that the critical value, this one is exactly negative 1.28. So this is our first critical value. And immediately you can write the second one without, you don't have to compute CV2. You can say it's just 1.28. And so this one is negative 1.28. So see how fast is it? Please always compute the negative critical value if you have a two-tailed test, because it's very easy from the table. If you wanted to find this one, then you have to do 1 minus the area above it. It will be longer, as you can imagine. So better to compute CV1 and then take its negative immediately to get CV2. So let me now answer the question. So you can say, therefore, because we have a two-tailed test, our first critical value, CV1, is negative 1.28, and our second critical value is 1.28. So this would be our first thing, and actually it solves the question, but because I also asked you to express the rejection region and the non-rejection region mathematically, we will have to add this. So you can say that from knowing the critical values now, they separate the rejection from the non-rejection region. So the rejection region where you reject the null hypothesis, in this case, is z less than negative 1.28 or z bigger than 1.28. You need to take anything that is less than the first critical value and anything that is bigger than the second critical value. So this way you cover this part here and this part here. Those are the z's that you would reject the null hypothesis if you get from the formulas here. Okay? And also I can say, and the non-rejection region in this case is, and you notice it's the one between the two. So it's anything from here to here. So let me use a different color. So let's use red. This is the non-rejection region, anything here. So how do we describe it mathematically? It's any z that is between the two critical values, between the first one, negative 1.28, and the second one, 1.28. So this here is our non-rejection region. Make sure you don't confuse this with the p-value method. I would say that the p-value method is more straightforward than this traditional or critical value method or z-value method. Because you will see when I solve questions about the p-value, it's very straightforward. But for this one, if you understood the three examples, this one, and this one, that's all what you need to know. And please remember that the question will also give you x bar, mu, sigma, and the sample size, or s sometimes, not sigma. So you need to compute the test statistic. So just want to tell you here, test statistic is z or t, depending on the situation. So now I will stop this video here, but the next part is going to deal with the t, this one here. What happens if you are in the situation where sigma is unknown and your population is normally distributed? This is when you use the t distribution. So this will be the next part, so please watch it. I hope that by now you understand the z test very well in the three cases. Those are all the cases that you can get. The only difference that could happen is that the alpha that is given to you will be different, not 0.015, it might be 0.01 only, or 0.03, anything, but the way that it's solved is the same. I hope that you understand the difference between the rejection region and the non-rejection region in each of the three cases, because the three cases are different. Right-tailed, and here left-tailed, and this one two-tailed. So this will end this question.